Finally, let's do an actual example of a hypothesis test. Here's a situation. Okay, so it says that this gene is linked to breast cancer. It's believed that 12% of all women with breast cancer, family history of breast cancer, have this gene. Okay, so this is the belief. So this is the hypothesized value. Okay, keep on reading. It says that they chose 169 women. That's the sample size. And of that 169, 27 of them had the gene. Okay, I don't know what that 2 is. Does this data suggest that more than 12% of women with breast cancer have this gene? Okay, so here, more, that's the greater than sign. Setting up the hypothesis is the first and most important part. The null hypothesis is that the proportion is less than or equal to 0.12. The alternative, that proportion is greater than 0.12. How do I know it's greater? This says more, not more than or equal to. There is no equal sign here. It's just strictly greater. Because there's no equal sign, I know this is the sign in the alternative. There it is. Okay, so what is P again? Proportion of women with history of breast cancer who have this gene. Let's find the test statistic. Here's the formula. Out of the 169, I found 27 of them. Okay, so 27 out of 169, subtract the hypothesis, which is here in the hypothesis. Okay, so 0.12, and again on the bottom it's the hypothesized. So 0.12 times 1 minus 0.12 all over 169, square root. Here's the test statistic. To transform this into a p-value, okay, if it's me, I like to draw the pictures. Look at the sign in the alternative. It points at which side the p-value is on. It is going to be on the greater than side. Here is my test statistic here. Okay, so I'm trying to find out what this area is because that is the p-value. Okay, so 1.5 and where it matches up with 0.09 on my Z table. I would look at where these match, and I find 0.9441. Again, this is the cumulative area. If I want this area, which is the p-value, of course I have to do 1 minus that. So here I get a p-value of 0.0559. Okay, so now we need to make a decision on this. Okay, is this big or small? Okay, before you answer, you need to have something to compare it to. Provide a conclusion testing at the 5% level of significance. So alpha is 5%. What we do is we compare the p-value, okay, to alpha. So I hope you didn't say that it was small because you don't know what you're comparing it to. Here, 0.0559 is actually larger than 0.05, which is alpha. So here p-value is large. When you have large p-values, that means you will fail to reject the null hypothesis. Here's the null hypothesis. You are failing to reject it. So this is the idea that seems to be supported. Here's a statement we can say. Based on this data, again, of course, this is always going to be based on the data. It appears that the proportion of women with history of breast cancer who have this gene is not statistically or not significantly larger than 0.12. Okay, so let's see. What did we just say? Here we think the hypothesis is that the proportion is 12% or 0.12. Okay, so when we took a sample, we got 27 over 169, which is approximately 16%. So here, the question that we're really asking is 0.16 larger than 0.12? I think the answer is obvious, yes. 16 is larger than 12, that is true. However, the question that we actually answered is 16 significantly larger than 0.12? And here we've found, because the p-value is large, we're saying no. 0.16 is not significantly larger than 0.12. Let me show you how we can do this in minitab. Okay, so when we go to minitab, we go to stat. We go to basic stats. We're talking about proportions. Okay, so you've got two options. Are my data in a column? No. Do I have summarized data? Yes. The number of events here, let me find my notes. I think it was 27 successes, or 27 people happened to have the gene and a history of breast cancer. Okay, out of, how many people did we ask? 169. We're going to perform a hypothesis test, so we want to check that off. And we are assuming that the hypothesized value is 0.12. Okay, so let's also check on our options. Okay, here we said that alpha was 5%. So therefore, the confidence level is 95%. The sign in the alternative hypothesis was the greater than sign. So here, less than, not equal to, or greater. It was the greater than sign. And again, anytime that you're using minitab to do this kind of thing for this course, you need to make sure that you've got normal approximation method selected. I can press OK, and I can press OK. This here, it says my Z value. This is the test statistic. You can compare it with our test statistic, which is similar. Okay, just a little bit of rounding. And here is the p-value. Okay, so here is the p-value, 0.056. What did we get? Okay, so we said the p-value was 0.0559. Minitab says it's 0.056. Here our test statistic is 1.5907, and Minitab says the test statistic is 1.59. We're getting the similar results.